This video is an extension of my previous video, Algebra Review for Calculus 1. Specifically, I am extending Set 1, and you can see here, this is now going to be 100% free. So it's no longer for sale. You can now watch it for free here on YouTube. So if you haven't watched the previous video yet, I highly recommend going back to it and watching items number 1 to 8, since those are the concepts we'll be using for this video. You can refer to the timestamps in the description for your reference. So for today, we're going to be reviewing the foundations of algebra. We'll start a little bit with the order of operations, simplifying algebraic expressions, and solving linear equations. Then we'll proceed to analyzing and solving single variable word problems, and then proceeding to the concept of factoring. So for the first one, we have the order of operations. It follows PEMDAS, which is parentheses, exponent, multiplication and division, and then addition and subtraction. So for our first item, let's evaluate this. We can see that the first ones we have are parentheses and exponent. So since these are actually in separate terms, we can do them independently. So you can see 3 times 2 is going to be 6. And then 5 is squared is going to be 25. So we just copy everything else. And here, since you can see that 7 minus 4 is in a different term than these ones, we can go ahead and solve that. Now we can proceed, and we see that we have 2 fractions, here and here. So the fraction is a grouping symbol, and it can be treated like a parenthesis. So regardless of that, in PEMDAS, we always do the inner fraction first. So 48 divided by 6 is 8. And now here in the fraction, we have to add 8 and 25 first because of PEMDAS. So you might be wondering, why do we do this first? As I said earlier, the fraction bar acts as a grouping symbol. So in some schools, it's taught as PEMDAS or GEMDAS, with G being grouping. And it also makes sense because before dividing, you need to add everything in the numerator. So this is going to be 33 over 3, or 11. So for the next item, we have this. We have to simplify this. So again, we have a parenthesis inside a parenthesis. So we have to do the innermost ones first. So in PEMDAS, we have to do this one, and this one. Now pay attention and see that the negative sign is inside this parenthesis. So when we say it's something like this, negative 2 raised to the 4th power without the parentheses, that's 2, 4, 8, 16, negative 16. But if we have the parentheses, sorry, wait. But if we have the parentheses, it's actually going to be positive 16. Because if you square a negative number, you're going to get a positive result. And this is true for every even exponent. So if you see 4, 6, 8, or etc., it's going to always lead to a positive number. So for this one, negative 3 raised to the 3rd power is going to be negative 27. Because we're multiplying 3 negative numbers, which will yield a negative number. So we have 16 and negative 27. So now we can proceed to multiplication in PEMDAS, because we can see this is a separate term. It doesn't affect the other one, so we can proceed here. So now it's best to proceed inside the parentheses. 16 minus negative 57. So if you see negative, sorry, if you see minus a negative number, you can simply rewrite it as plus. So 16 plus 57 is 73. So this is our final answer. Now it's time to proceed to simplifying algebraic expression. So here are some terms you need to know. The degree is the exponent on the variable. It usually tells you if it's linear, quadratic, cubic, etc. The coefficients are the numbers beside the variables, but if there is no variable, it's called a constant. So this is called a constant because there is no variable to change it, so it does not vary. Uh, so these are terms with variables. So both the terms with and without variables are called terms. They are separated by the plus or the minus sign. So if you see something like this, x, y, these are two variables, but it's still counted as one term. So let's try this. It's time to simplify completely. So when we say simplify completely, we want it to be in the simplest form where we combine like terms as much as possible. So here, we're going to use the distributive property. 3 times 2x, and then 3 times negative 4. So we're going to do it for these numbers. So you can see 6x minus 4, sorry, minus 12, and 4x minus 8. Now for this one, you can see that this 5 here has a negative sign. So it's up to you whether you want to use that in the distributive property or not. But generally, I find it faster to include it. So negative 5 times x is going to be negative 5x. And negative 5 times positive 6 is going to be negative 30. So we have to be wary of the grouping signs. A common mistake some students make is they multiply the first one by negative 5, but then they forget to do it here. So now it's time to add like terms. We have 6x, negative 5x, and 4x. So basically what we want to do is 6 minus 5 plus 4. That's going to be 5x. And then we add the remaining constant. So we have 5x minus 56. So 56 comes from here, here, and here. So alternatively, if you do not want to multiply this negative sign straight away, you can just multiply the coefficient first. 5 times x and 6. But generally, it's going to be slower because you're going to end up multiplying it anyway. So for number 4 and 5, let's simplify this. So when simplifying, you're going to need to factor it. You need to find out what's common in between these two. So earlier, we see that there is a factor, there's a coefficient factor outside. And we use the distributive property to distribute it. So we have to find its opposite. So if we distributed earlier, now we have to regroup them. So if you see a variable like this in the denominator, that's generally a hint on what you're supposed to find here. So in 5x squared, there is 5x times x. In 10x, there is going to be 5x times 2. So now you have to rewrite this as 5x times 2 minus x. Sorry, 5x times x minus 2. So you have to pay attention to the sign here. So now you are able to cancel it. So the answer is going to be x minus 2. If ever you want to double check it, you can simply multiply it again. So 5x times x is going to be 5x squared, and 5x times negative 2 is going to be negative 10x. So to simplify this, we can use the distributive property or the special product. So first I'm going to show how to do it with the distributive property. You have 2 times x plus 3 times x plus 3 again. So what you're going to do is multiply x times x and then x times 3. And then you have to multiply this one, 3 and x, and then 3 plus 3. So combining like terms, you're going to get this. So from here, you now need to apply the distributive property again. So multiply 2 to all of the terms, and you get this. So this is the simplest form of it, but there's actually a faster way to do it. So recognize this pattern. So you can see that when you square it, the middle terms are always going to be the same. So you can just have the pattern like this. Square the first term, square the second term, and then multiply the two terms by 2. So we have 3x times 2, which is going to become 6. So x squared plus 6x plus 9. So the special products like these are going to be in an upcoming lesson, but if you want, you can also view the free version of it on YouTube, which already contains a bit of that. So on to the next one. Now it's time to solve linear equations. So in solving linear equations, we use the properties of equality. So there are a lot of them listed on the screen right now, but basically what we have to do is treat it like a seesaw. So if this is an equation, anything we add on one side must have some equivalent on the other side. Because if we don't, it's not going to be equal anymore, and the scale is going to flip over. So the ones we're going to be using a lot are going to be these ones: addition, subtraction, multiplication, and division. So these are going to be the first ones for solving. But later in the word problems, we're going to be using these ones a lot more often. Because in algebra, we're not only using things to solve the equations that have been given, but rather we're forming equations based on the scenarios. So for these ones, 4 to 7, addition, subtraction, multiplication, and division, let's practice them here. So now it's time to solve for x. So we're going to apply the steps we did earlier, the distributive property. Okay, and we continue from here. So it stated earlier that the properties of equality, whatever you add on one side has to be added to another. So we have a shortcut for that called transposition. So normally the long way is you subtract a number from the other side and then you want to make it 0. So here, negative 2x. So this is going to become 0, right? So since you subtracted 2x here, you have to subtract here from the other side as well. Similarly, for negative 6, you want there to be no numbers beside x. So we're going to add 6 on both sides. However, there is another shortcut for that. You can just swap it to the other side with a different sign. So this one is positive. It's going to become negative. And this one, negative 6 is going to be positive 6 plus 8. So now we solve. We can have 3x minus 2x is x, and and 6 plus 8 is 14. So if ever you do it the other way around and you move x here, it's going to be negative x, and then you move 8 here, it's going to be negative 14. You're going to end up still with the same answer. You can just multiply both by negative 1 to make the signs disappear. So 14 equals x is going to be the same as x equals 14. But now we have to focus on inequalities. So when you solve this inequality, you'll notice that it uses a greater than sign. So we start as usual. We move things to the other side. So here we moved 3x to the left. So 2 minus 3 is negative 1. And then 5 was moved to the right. So 5 plus 1 is now positive 6. So earlier, we can see that we can simply flip the x and the number sign around. However, if it's like this, we need to take into consideration. So here, if there is positive x and something like this, you need to flip the sign every time you reverse them. Because, for example, if we say that x is equal to 7, so 7 is greater than 6. If we flip it around, 6 is not greater than 7, but 6 is less than 7. Similarly, for negative numbers, for example, negative x is greater than 6. We have to write it as x is less than negative 6. So basically, if there is a negative sign besides x in an inequality, you need to swap the sign whenever you multiply by negative 1. So here, let's have a sample for this. Negative x is greater than 6, so it has to be a negative number. For example, negative 10. So negative 10 is positive 10, which is greater than 6. Similarly, we have here, negative 10 is less than negative 6, which is true. So when you see something like this, you need to multiply by their LCM, or the least common multiple. Or you can cross multiply. So what I did here is I multiplied each item by 4, since 4 and 2 have an LCM of 4. So what you have to do is multiply both terms by 4, as well as the other side. Okay, so now it's time to solve for x. First is we have to distribute negative 2. Remember, you have to include the negative sign. So it's going to be 3x minus 7 minus 2x minus 10 is equal to 4. Next, we isolate 3x and negative 2x. We have positive x minus 17 is equal to 4. So that will lead us to x is equal to 21. So now let's continue with single variable word problems. So this is going to be the longest part of this set. So for number 9, the sum of the consecutive even integers is 90. What are the integers? So in here, we're going to learn about representation. So the sum of the consecutive even integers involves three numbers. So one of them has to be x. So when we say consecutive even, they have to be next to each other with a difference of 2. For example, 2, 4, 6, 8, 10. Those are consecutive even integers. So from that pattern, we can have x, x plus 2, and x plus 4. But an important thing in representation is we have to make it as simple as possible. So here we have a difference of 2. We can also have a difference of 2 going backwards, which is x minus 2. So the reason we're using x minus 2 instead of x plus 4 is because this will simplify into 3x and it will also not affect the sum. Since we're just representing this variable with no other information than their sum is 90. So here it is. As I mentioned earlier, it should simplify to 3x, where x is equal to 30. Now, the important part of representation is to know when to use the numbers again. So x minus 2 is going to be 28, and x plus 2 is going to be 32. So these are our three consecutive even integers. So for number 10, a bus leaves a station traveling at 60 kilometers an hour. 2 hours later, a car leaves the same station traveling at 90 kilometers per hour in the same direction. How many hours will it take for the car to catch up to the bus? So what we need to know is that distance is equal to speed times time. This is from the equation speed is equal to distance over time, where we just multiplied both sides by t. Next is for the car to catch up to the bus, we need to have their distances traveled be equal. So what we're going to do is find the speed and time of the bus is equal to the speed and time of the car. So this will be our representation. 60 is the speed of the bus. 90 is the speed of the car. Likewise, x plus 2 is going to be the time of the bus, since it has been traveling for 2 hours more than the car. So the car is going to be our x variable. It's the unknown variable. So now we're going to have the solving of x. So distributing 60, we have 60x and 120 is equal to 90x. So 120 is equal to 30x, and we find that x is equal to 4. So that means the car has been traveling for uh 4 hours. So for number 11, we have train problems. Train A leaves the station at 7 a.m., traveling at 60 kilometers an hour. At 8:30 a.m., Train B leaves the station on the same track, traveling at 90 kilometers per hour. At what time will Train B catch up to the first train? So this is similar to our previous one, except now we're using the time instead of the we're using time instead of hours. So for A, Train A leaves at 60 kilometers per hour, and it left 1.5 hours before train B. And for train B, we represent it as 90t. So similar to the last item, we distribute 60 and solve for t. So we get t is equal to 3. However, our final answer should be in an hour format, since that is what was originally given. So 3 hours past 8:30 a.m. for train B is going to be 11:30 a.m. So number 12. Jane can finish painting a fence in 6 hours. Peter can do the same job in 8 hours. If they work together, how long will it take them to finish painting the fence? So this is an example of a work word problem. So what you need to know is that there is only one work which can be represented by, the number 1 or 100% of the work. Every hour, they can finish some part or some fraction of the work. So working together, we need to add how much work they can do in an hour together and see how many hours that is. So this will be our representation. 1 is the entirety of the work, the 100% of the work. X plus 6 is going to be how much work Jane can finish in 6 hours. X over 8 is going to be how much of the work that can be done in 8 hours. So in total, this is the work they can do in all of the hours. It's equal to the total work. So what we did here is we did cross multiplication. So we multiplied all sides by 48. So you can see 48 divided by 6 is going to be 8, and 48 divided by 8 is going to be 6. Usually, we just do cross multiplication. Alright, so now we have 8x plus 6x is equal to 48. So this simplifies to 14x is equal to 48, which simplifies to 24 over 7. So it will take them a little bit over than 3 hours to finish painting the fence. So this is going to be 3 point something, 24 over 7. So here we have another work word problem where a water tank can be filled by an inlet pipe in 5 hours, and a drain at the bottom can empty the tank in 8 hours. So if both the inlet and the drain are open, how long will it take to fill the tank? So the first thing we need to know is that the inlet pipe is is positive x plus 5, since that's the work that it can do, and the drain at the bottom can empty the tank in 8 hours, since that is the work it can prevent. So negative x over 8 actually. So the first thing we need to do is check if the work can actually be completed, because sometimes, for example, if you're using a faucet and the water can drain faster than you can fill it. So even if you leave the faucet on all of the time, sometimes it won't be able to be filled. So you need to check if that's the case here. So as we can see here, 8 hours compared to 5 hours. It takes longer to empty it than to fill it. So of course, it can still be filled. What we have is x plus 5 minus x minus 8 is equal to 1, or the entirety of the work. Cross multiply. 8x minus 5x is equal to 40. 3x is equal to 40, and x is equal to 40 over 3. So this is going to take around 13.33 hours, or 13 hours and 20 minutes. So number 14. A fruit vendor wants to mix mangoes costing 80 pesos per kilo with mangoes costing 100 pesos per kilo to create a 20 kilo mixture that will sell for 110 pesos per kilo. How many kilos of each type of mango should be mixed? So what we need to know here is that we're mixing things of different prices to achieve a fixed amount. So this is like nut mixes. So like snack mixes sometimes have different types of nuts. They're usually a lot of peanuts and then only a little bit of almonds or cashews. So that's an example of a mixture word problem. We need to find out the amounts of each. What we need to know is that the prices are fixed. The amount of the final mixture is fixed, but the ones here on top, 80 and 120, are not yet fixed. So what we need to do is assign a variable x, which is an unknown amount, And when we add it to another amount, it should equal to 20. So that's going to be 20 minus x. So when you add 20 minus x plus x, it's just going to be 20. So this will be our representation. Again, we are adding the cheap mangoes with the expensive mangoes to create a mixture. So let's see. So we have 80x plus 120 times the value of 20 minus x is equal to 110 times 20. So for each term, we have the price times the amount. Next, we distribute and solve for x. So distributing 120, we have 2400 minus 120x. And 110 times 20 is 2200. So we isolate the terms with x. That's going to be negative 40x is equal to negative 200. And then we solve for x by dividing both sides by negative 40. We have x is equal to 5. So going back to our representation, we have 5 for the cheap mangoes and 15 for the expensive mangoes. So this is our final answer. For number 15, we have this one, but with money. Anna invests 20,000 pesos in two accounts. One account earns 4% annual interest, and the other earns 6% annual interest. If the total interest earned in 1 year is 1,040 pesos, how much did she invest in each account? So the things we need to know here is that um, the principal times the interest rates, or either interest rate, should equal to the interest, like the amount of interest. So we can see here the total interest earned in 1 year. So in this case, if it's just 1 year and the term is not stated, we can assume that it is annual. So since it's annual and just 1 year, we don't need to worry if it's a simple interest or a compound interest because it's just 1 year anyway. So we're going to use simple interest. We need to learn how much she invested in each account. So this will be our representation. So as you can see here, we did the similar thing as the last item. We're adding up to 20,000. So we have x plus 20,000 minus x. Now here is the interesting thing. For the interest rate, 4%. So percent. When you see percent, it means per 100. So 4 times per 100 is going to be 0.04. 6 times per 100, or simply 6 over 100, is going to be 0.06. So what we need to know here is that we don't know the interest rate of the total, but we do know that we are looking for the interest earned. So the interest earned in 1 year, so the interest earned in 1 year is going to be 1,040. So the interest earned for each account is going to be the interest rate times its principal. So that will be our representation. We have 0.04x plus 0.06 times the value of, sorry, this is a typo. It should be 2000 minus x. Okay, let's proceed. What I did here first is to multiply both sides by 100, since it's difficult to divide with a lot of decimals. So here for the 4%, it just became 4 after multiplying both sides by 100. 6% became 6, and 1040 became 104,000. So now we distribute 6 to get 120,000 minus 6x. So isolate the terms with x on the left side, we have negative 2x minus negative 2x plus 120,000 is equal to 104,000. So that's going to be negative 2x is equal to negative 16,000, which gives us x is equal to 8,000. So going back to our representation, she invested 8,000 in the 4% account and 12,000 in the 6% account. So for number 16, we have an age problem. So 3 years ago, Carla was twice as old as Marco. In 5 years, the sum of their ages will be 55. So how old are Carla and Marco now? So the first thing you need to know in these age word problems is to identify the time periods. So this is going to be 3 years ago. So that's going to be their age minus 3. In 5 years, that's going to be their age plus 5. And their current age now. So let's see, how do we represent this? So 3 years ago, Carla was twice as old as Marco. So that's going to be, Carla is going to be twice as old as Marco. So we don't know how old Marco is. So we can represent that as x. Or rather, x minus 3. So this is going to be 2 times x minus 3. Remember, don't use 2x because she was twice as old as Marco. Keyword was 3 years ago. So that's why you have to use x minus 3. So Marco is our main representation. He's going to be x. So in 5 years, the sum of their ages will be 55. So what you need to know is, okay, this is what you need to know. In 5 years, Marco will be x plus 5. And for Carla, we don't know what her age is, but we do know that 3 years will pass to the going to the present, and another 5 years will pass going to the future. So she will be 2x minus 3 plus 8. So a similar thing will be considered for her age now. So our representation is now complete. So now it's time to make the equations. So in 5 years, the sum of their ages will be 55. So when we add these, it should equal to 55. So first we solve for Marco's age as it is the smallest, actually the simplest number. So here we have Carla's age in the future, 2 times x minus 3 plus 8. And then we have Marco's age in the future is x plus 5 is equal to 55. What we have to do is to distribute 2. So that's going to be 2x minus 6. And then all of the terms with x need to be isolated. So we have 2x plus x is going to be 3x. And 13 minus 6 is going to be 7. So 55 minus 7 is 48. And 48 divided by 3 is 16. So we know that now Marco is 16 years old. So in the future, he's going to be 21. And in the past, he would be 13. So the simplest thing we can do now is to check here. Plug in 16 here. So 16 minus 3 is 13. And remember, those years ago, Carla was twice as old as he was 2 years ago. So 2 times 13 is going to be 26 plus 3. So we have Carla is 23 years old and Marco is 16. Sorry, Carla is 29 years old. This is a typo. So it's always important to double check your signs. So another way you can double check it is check here for their past ages. So x minus 3 is 13. So you should know that here Carla is 26 plus 3 is 29. So that is the last of our word problems for linear equations. The last number for this video will be the concept of factoring, which will be used more in the second video. So now we have to factor x squared minus 16. So for those who know special products, this is going to be x plus 4 and x minus 4. What you need to know is, in order to factor effectively for terms, you need to know your squares, since most of the times squares will be the things used. So generally, in linear factoring, in quadratic factoring, you want two terms. So you have to look for pairs. So this is going to be 1 times 16, 2 times 8, or 4 times 4. So you need to look for pairs. So in the next video, we're going to discuss special products. We're going to see how this is related to this. So thank you so much for watching. I hope you were able to enjoy this video.